right, let's take a look see at problem number 1 for conservation of energy, where we have to start with understanding that initial mechanical energy that is present in the beginning equals the final mechanical energy in the end. The trick about these problems, you need to understand, kind of like step back, look at the big picture, and identify the types of energies that are present. So we have a diver, he jumps, that implies motion, and they actually give us the initial speed to be 5 meters per second, and he is above water. They give us initial height of 12 meters. So that gives us potential gravitational initial and kinetic initial. Potential energy gravitational initial plus kinetic energy initial equals, what do we have in the end? We're assuming no air resistance. That's an important part because that allows us to say that energy is conserved. There's no friction, no air resistance, no other non-conservative forces that allow us to lose or transfer energy that is mechanical into something that is not mechanical, like heat and sound and whatnot. Kinetic energy plus potential energy in the beginning should be equal to what? He is moving and is above water by 2 meters. So again, we have potential energy gravitational final plus kinetic energy final. Now that we have this first set up, we're going to plug in the formula mass times g times initial height plus mv initial squared divided by 2 equals mgh final plus mv final squared over 2. All we did is first identify the types of energy, then use the formula for those particular types of energy. Then mass, as you can see, is everywhere. Now be careful. I don't have any springs here. And potential gravitational and kinetic energy all of these energies have mass in them. That is how I can cancel mass. If there's a spring, that's going to be a little bit different. And now we'll multiply by 2 to get rid of the denominator. So I have 2gh initial plus v initial squared equal to 2gh final plus v final squared, and that's what I'm after. So I'm going to drag this over here. So v final squared is going to be v initial squared plus 2g I'm going to factor out, and then I have h initial minus h final. There we go. If I square root this, I will get actual final 25, which is v initial squared, plus 2g is 19.6, and then times 12 minus, this is 12, and that is 2 times 10. So then you grab your calculator and calculate 25 plus 196, 14.9 meters per second is your final velocity. That's how you solve problem number 1. Problem number 2, very similar to it, and I will see you in the next video.